Hi everyone, welcome to the course of antenna designing. Okay, so in this session we'll start designing our antenna on HFSS, that is high frequency structure simulator. Nowadays that ANSYS have given a new term as ANSYS electronic desktop, that is AEDT. So in this it is having a complete package which is, as you can see, HFSS, Q3D, IcePack and Maxwell. So all are somewhere or somewhat totally related to electronics. Okay, and simulation related for automobiles and any other mechanical parts, so many. Okay, so as you know, we will be requiring HFSS only, so I'll insert a one HFSS template. So in previous session, I have told you that we'll be designing our basic patch antenna, which is based on 3.5 gigahertz. So for this, first of all, you have to set the solution type as a driven model. Okay. Anyway, in case of coaxial cable, we will be taking a driven terminal for the solution type. Okay. And remember that regarding the units, what I am considering here is millimeter only. So I'll check with the units, which is by default millimeter. So I'll untouch it, will not change it anymore. Okay. Now regarding this local coordinates, I'm not using in this anyway. Basic by using some basic equations only, I'll create the full design, and later on we'll simulate the design as well. Okay, so first we will start with the substrate, which is a basic element only. For this, go to the brick option. One more time I'll show you guys. As you can see in this draw box, anyway brick is for CST, forgot actually. So in this box you choose, and then randomly you draw once, and then on the left side you will see the box option. Okay, that is box 1. Double click on it. Now for this we will give a name as substrate. Okay, regarding the material, already the specification I've told as FR4. Okay, so FR4 will type, will load it. Okay, and regarding the color, preferably I will give it brown only, and slight I'll change the shade, and transparent also I'll do, so that I can see the patch and ground in both sides while in case of rotating. Okay, after that I'll click apply, and further, now dimension I have to justify for the substrate. But before that, please remember that in this case, in HFSS, we are first defining the position. Okay. During CST, if because some of the participants are already attended that course, so they might know. In the case of CST, I have defining the correct dimension only, as you can say. So there is no need of position and somewhat, because it is considered as a local coordinates. We are using a local coordinate in this case. In this case also, we can change the coordinate system as global and relative, but since it is a very basic design also only, so I'm not considering any local coordinates or relative coordinating system in this case of HFSS. Okay. Regarding the dimension of the substrate for the 3.5 gigahertz antenna, I'll considering as a parameter wise, so that in if anyway in order to change the value again, so I can change it later on. And if you are giving a numerical value, so you have to calculate each and every value again and again. So by using mathematical equations and all, it will be easier while designing. Okay, so I'll start for the position. It will be minus ls by 2 comma minus ws by 2. Okay, comma, it will be 0. Okay, regarding this, now it will ask for the dimension or value for that variable. So don't forget to give unit type as length, because it is length only. Otherwise, if you by default, if you are missing it, then it will be a problem. It will change as per the global, I guess, whatever. So Regarding the length of the substrate will be 31 mm. Regarding the width of the substrate, I am considering as a 40 mm. Okay, so for 40 mm. Okay, okay. Now in this X size will be LS because full size I am considering. Full size will be, and this will be TS. TS is nothing but the substrate thickness, which is 1.6 mm. Okay, so and you can see that evaluated value is also given because the value I'm giving as a mathematical equation, so in some expression manner, so that's why it is calculating a evaluated value as well. Okay, I'll click on apply, and in order to fit the full structure in one plane, in one within the workspace, you can press Control plus D. Okay, and further, in order to rotate it, you can use Alt button along with your left mouse. Okay, as you can see, you can rotate it, and similarly you can rotate it clockwise as well in this case. Okay, now we'll create our ground plane. Actually, ground plane will be somewhat like this, and some thickness I am also considering because anyway this copper cladding will also have some thickness. So in short form I will give the name. Regarding the material, I will give a name as copper. Then further I will give a color as yellow only, little bit lighter shade I will select. Click on OK, and transparency also little but somewhat it will be required. Regarding the dimension, as you know, dimension will be same only, so I'm using the same parameters. No, I'm not using any new parameters for it. Okay, now regarding this also it will be LS and it will be WS. Now in this case you have to give a minus TP. What is minus TP? Now TP is nothing but the thickness of the copper cladding. And further you have to think that regarding the thickness of the copper cladding, it has to be minimum of 0.017. Okay, anyway in this case I am using it 0.035 for copper cladding, and it has to be same on either side of the substrate, that is on patch as well as ground both. Okay, I'll click on apply. Okay, we'll click on OK, and again we'll rotate it. We'll zoom it with the help of zoom area. Again I'll change it. Okay, now again I will back to it with the Control plus D option. Okay, and now we'll create our patch with the same option. Okay, patch, and material will be copper only. It will be yellow, the color I'm taking. Transparency as of now it is not required. Regarding the dimension, again I'll start with the minus LP by 2 comma minus WP by 2 comma TS. Why TS? Because on the top of the substrate I have to make. So the thickness of the, or you can say the position for the substrate I have taken as 0. So 0 to it has gone to positive Z axis, that is TS. So after TS my patch will come. So that's why I'm giving a position from TS. While designing on CST as well as HFSS, concept some in direct or indirect way it will be similar only, but you have to understand the logic that where the design will be drawn. Okay, and further again it will ask for the value for that variable. Now my length of the patch will be 19.2, which I am considering, and regarding the WP, that is length width of the patch, I'm considering as 37. Okay, now further it will be also our patch only, so it will be LP, it will be WP, and it will be TP. Okay, we'll click on it. Okay, again we'll see with the rotation option, and we can zoom as well with the help of zoom option. Okay, yeah, so we can see it is on top only. Now our main part, that is feed, because anyway we have to energize our antenna. So with this I'll energize it. Again I will give a name on the panel. So give a name as a feed, then material will be same copper, color will be obviously be same anyway, after that it will be united, so not an issue. Okay, now I'll click on apply and click on OK. Regarding the dimension, it will be minus LP by 2. Now I'll first write the expression, then I will show you why it is so. Okay, WF will be 3.11, that is calculated with the help of EM microstrip line. Okay, it will be LF, that is 5.9. You can measure this quantity as well with the help of measure option. Okay, anyway it has to be on positive side. Now what I will do is that I will check once again whether it is came on correct way or not. That I have to check. Zoom area. Okay, it is coming somewhat. Anyway, because of the color difference, it is looking like a very different way, and further it is not properly aligned. What I am able to see, so it has to be minus actually, not plus. Yeah, now you can see it is coming up proper only. Regarding one more time, I will see whether it is coming on top only or it has to be aligned. Yes, as you can see in this, it is aligned. Regarding the designing, if anyone, if any of the my participant is very newly in this designing, and then I will say that try to analyze the design while you are creating on the software. You have to develop the analytical skill so that you can analyze your design, how it is making. Means you have to imagine in your mind that how it will look like. So first thing. Second thing, regarding the coordinate is the major part in this. So coordinate has to be chosen very appropriately so that it will align it, your design will not be altered. Okay, and further I will assign one boundary, not boundary, but open region, which is based on 3.5 gigahertz. Okay, and further I will hide it with the help of hide selected objects, because I already selected that object, so it and clicked on this option, so it will be hide it. Now I'll unite this patch and feed. So select on patch and hold the control button and click on feed. Then on the modular option, go to the boolean, unite it. Okay, now whatever the color of the patch was there, so it is came to the feed as well. Okay, now I will assign it boundary of perfect electric. Okay, and further ground also I will select as perfect electric. Okay, so perfect electric too. On the project manager, on the left side, on the leftmost side, you can say in the boundaries have been selected, created for boundary 1, sorry, yeah, boundaries only, boundary 1 and boundary 2 for both the conductive layers. Okay, now what I'll do, I'll make one port with the help of sheet option. So in order to create a port, we know that we have to give it port, give the size from this side. Okay, so I will create it with the help of sheet option. But before that, I have to change the grid plane to YZ, because as you can see in the global coordinates, XZ is coming outer side. Now Y, this is vertical, and horizontal will be this Z axis. Okay, so we select the sheet, create it with the help of option. Okay, now give a name as port, color I am giving as red, it will be easier in order to distinguish. Okay, now create rectangle. Now in this case I have to give the dimension, not dimension but position where it will start. Now it will start from the ls, but first of all my y-axis will be 0 because it is not going to right side. As you can see in this y-axis, it is not going to shift in the y plane, only it will be shifting in the z, or sorry, yeah, correct, only it is not going to shift. So anyway, I'll give it name as ls by 2 comma minus 6 times wf by 2 comma minus tp. It will start from the tp, means from bottom side. Okay, now it has to be 6 times wf, and it has to be 5 times to the ts. Okay, we'll click on apply. We'll see whether it is properly aligned or not. Now in this case, why I have taken this cx, first of all I change the orient to top side and fit all. Okay, now this is my plane, this is my port. So in this case what I have did that first of all the position has to be ls by 2, means as you can see in this vertical direction it has to be in the middle way. And regarding this starting point, it has to be start from the ground plane thickness. Okay, and further the total dimension will be 6 times wf, and whatever the position which I am starting, it is half of that full value, so that only I have considered minus 6, minus of 6 times, because it has to be start from the minus side, minus x plane. Okay, now and to total height it has to be considered generally 5 times of the thickness of substrate, so that only I'm considering. Same design I will also compare it with the help of CST. In that also I have designed, so we'll compare it and that too I'll compare maybe probably S11. Okay, so that we will check. Now we'll click on OK. As you can see already I've made it, so no need to bother about. Now I'll change the selection mode because I have to create a backing, or you can say a why I'm creating a backing means whenever I'm exciting the antenna, so field has to be given with the help of port only. Okay, so since this port is inside the boundary whatever I've created the region, okay, so that has some backing needs to be provided. Otherwise if this boundary, the region which I have created, open region at 3.5 gigahertz, it is coming, this port is coming outside, then there is no needed of backing. But it is inside, so field should not reflect and re-excite the antenna. So that's why this backing is needed, which is perfect electric conductor. So first of all I'll change the selection mode to the face and select the face. Now on this modeler option, go to the surface, create object from the surface. Okay, now from this same only, let it be select only, I'll thicken the sheet to 0.5. Okay, now what I'll do, I will rotate it once and I will show you guys whether it is as you can see, port is different, that face is different, and this full object which I have created, that is different. Okay, so that face is not selected. So that object only I will assign material to PEC, that is perfect electric conductor. Okay, after that, so that we have created. Now I will save this design first of all in my system in HFSS as project 1. Okay, now what we have to do, I have to assign a port, or you can say assign excitation to the port, and that to only phase. So I'll select its port, assign excitation port, then wave port. Okay, and in this case, since my model is a driven model type, solution type, so I will perform it. Again, I'll zoom it, and as you can see, whenever you will, whenever your cursor will hover on your edges or on, and whenever that midpoint will come, automatically its shape will change from diamond to this triangle, as you can see in this screen. So, but I have to start it from the ground, so I will select it on the top side. Sorry, it has to be perform again. So it has to perform again at bottom side only. Okay, now this to this. Okay, yeah, now it is defined. In this case also, I'll say renormalize all modes, finish. Okay, I'll again come back. Excitation has been excited to the face, as you can see in this. Okay, boundaries I've also assigned. Okay, now I'll do one thing, that is on design settings, that enable material override. So this, it will not be a hindrance. Generally I will use this, because what happens is during the meshing, whatever the meshing is done by default, that will be done in this case also. But sometimes material will override some different material, suppose dielectric conductor, so at that time it has to perform very efficiently. But in order for a simpler complex, simpler computations and all, we'll generally prefer that. Okay, now the things have been created. Open region we have created, and wave port also we have assigned. Now we will do our analysis setup. Analysis setup in order to perform the frequency from the simulation. So I will keep the frequency as 3.5 gigahertz, for which we are designing our antenna. Then maximum number of passes will be 6, and maximum delta will be 0.02. Okay, I'll click on OK. Now it will ask for the sweep and the range start and stop. So I will give it 2 and 5. Okay, I'll save the save fields at interpolating. Okay, I'll click on OK. I will save it the design, and now our design has been completed. Analysis setup also has been made. Open region also created, excitation also given, and boundaries also assigned. Okay, now we'll go on the HFSS option, and validation check is there. Means before going to simulation, it will give a validation check whether any alteration, any disruption is there, or any modifications is needed on any steps has been forgotten. So one by one, as you can see, design settings, cable setup, 3D model, boundary excitation, mesh observation, analysis setup, just now only we have created, and optometrics and radiations, these already are performed very well. So validation, we have passed the validation hour. Now we will analyze this design. Okay, as you can see in this progress, it has been simulating. So once it will be simulated, we'll start our the analysis for the results of this design. Okay, so probably I'll be starting the results evaluation in the next lecture only, so that it will not be a too longer for you guys as well. So in this case, in this session, we have designed from starting and ending up with the result simulation. Since I have performed that simulation, that design override option in the design settings later on, so that's why it is giving us a warning, but it is nothing so much of concern. Okay, so it will about to complete, I guess. Yeah, it is completed now. Okay, show 9 message, it is already successfully completed. Okay, so in the next lecture we'll start our result evaluation. Thank you.